I've got one more example for you that you'll need for the homework problems. We're given a demand function and the equilibrium price, and we're asked to find the consumer surplus. Now, our consumer surplus formula to get the area underneath the demand curve and above the equilibrium price is definite integral of the demand function minus the equilibrium price. And our limits of integration go from 0 to the equilibrium quantity. Do you see a problem we've got? We're not given the equilibrium quantity. So we need to come up with that ourselves before we can figure out the consumer supply. Now let's recall what the equilibrium point is. It's the point where the demand and supply curves intersect. That means that it's a point that's on the demand curve, and similarly, it's a point on the supply curve. As long as we have one of those curves equations, and we have either x sub b or p sub b, we can find the other one by just plugging in. So if you need to find one or the other of those equilibrium values, you just use that the equilibrium price will be the price on the demand curve at the equilibrium quantity. Or if what you're given is the supply curve, you'd use P sub E equals S of X sub E. Now, if you're given X sub E, all you have to do is plug it into your function to get P sub E. In our case, we're given X sub E, so we're going to have to do some solving. Specifically, we'll solve the equation P sub E equals D of X sub E. In other words, 20 equals square root of 580 minus 5 times X sub E. So basically, I'm just plugging whatever I've been given into one of these formulas, whichever I've been given, and I'm solving for the unknown. So let's see. I guess I need to square both sides of the equation here to get rid of that square root. So I'll have 400 equals 580 minus 5x sub e. And then if I subtract 580 from both sides, I'll have negative 180 equals minus 5x sub e. Let's divide both sides by negative 5. And that gives me x sub e equals positive 36. Okay, we're ready to calculate the consumer surplus. We now know that our limits of integration will be from 0 to 36, and we're integrating the demand function, square root of 580 minus 5x, minus the equilibrium price, 20, dx. We're going to need a u substitution, which I do want to put on my paper so that the reader can tell what I'm doing. But I'm going to put it off to the side so that it doesn't interrupt the flow of my integration. We're going to let u be the thing inside the square root, 580 minus 5x. So du will be minus 5 dx, and that tells me that I should put in a minus 1/5 du for the dx. And by the way, I'm thinking of this as two definite integrals. In other words, I'm splitting them up across that minus sign. And I need to be aware of that because that u does not apply to the integration of the constant 20. Now, for the first integral, the integrand is now square root of u, which I'm going to call u to the 1/2, and then I have times minus 1/5 du in for the dx. I think I won't change the limits of integration here. I won't change them to u values. In other words, I'm planning to put the x's back in. And to remind me not to put in these numbers for u's, which is so easy to do, I'm going to note that those are x values. Now for the second definite integral, I can just go ahead and say the antiderivative is 20x, and I'm putting in 0 and 36 for those x values. Back to the first definite integral, the minus 1/5 can come out front. It just comes along for the ride. And then the antiderivative for u to the 1/2 will be u to the 3/2 divided by 3/2. And here's my limits of integration, but they're x values, so I'm going to write x equals 0 and x equals 36. Moving on to the next part, I will put in the 36 and the 0 for x. Back to the first one. Dividing by 3/2 is like multiplying by 2/3, and I'm putting in 580 minus 5x for u. That's being raised to the 3/2 power. Going from 0 to 36. 20 times 36 is 720, so that's what we're subtracting off at the end. Now I have negative 2/15 times 580 minus 5 times 36 to the 3/2 power minus 580 minus 5 times 0 to the 3/2 power. And we still have the minus 720 off at the back. $580 minus 5 times 36 is 400, so that's what we're raising to the 3/2 power there. 580 minus 0 is, of course, 580. That's what we're raising to the 3/2 power in that spot. We still have our minus 720. Using a calculator, 400 to the 3/2 power minus 580 to the 3/2 power is negative 5,968.25. Notice that the two minus signs in the first part of this computation cancel each other out. And finishing up the computation, again with the calculator, of course, we get 75.77. Let's quickly recap what we did here to get a better feel for it. I've gone ahead and provided a graph so that we can visualize what we did as well. In this problem, we were given the equation for the demand curve, which was square root of 580 minus 5x, And remember, the input of the demand curve is an X, which represents number of units produced and sold. And the output on the vertical axis, P, is price. We were also given the equilibrium price, which was 20. And we were asked for the consumer surplus, which is this area. So that was the question. In order to compute that, though, we had to know what the equilibrium quantity was, because that's one of our limits of integration. So we had to calculate that. Which we did by using the idea that the equilibrium price is equal to the p-value on the demand curve at the equilibrium quantity. And we calculated that equilibrium quantity to be 36. At that point, we were able to answer the question by calculating this area, and for that we got 75.77. I hope this helps you with the homework, but as always, if you have any difficulties or questions, please do ask. I'm happy to help.